Sorry, thank you very much. Thank you much for inviting me, and I'm pleased to share this material with you. It was actually specially created for you guys, and I've practiced it once, so hopefully I'll be able to fit it into our time and give some time in for questions. So let me share my screen. And somebody please confirm that you can see my screen.
Yes, we can see the screen.
Okay. So I was requested, based on work that I'm doing with your professor, to discuss some of the work that is going on and that I'm involved in. San Jose State University, for those who need a geography lesson on California, is in the middle of Silicon Valley in Northern California. So it is, you can walk to the Apple campus from my house. It's a very central location here. And to talk about work in two different dimensions of artificial intelligence, which is a very broad topic. The first is user experience for AI versus AI for generative creation of user experiences. And I have both, and I'm going to kind of just take you on a very high level tour, and hopefully have time for questions. This is a massive topic. It could be a multi-semester course, and I'm going to shove it into about 40 minutes. So some caveats. This is not about science fiction. I found this wonderful image of a sentient robot, and that's not what I'm going to talk about. And I'm also not going to talk about the core technologies of speech recognition and understanding of speech and things like that. My expertise is in interaction design. I am a user experience person, and I've been doing that since pretty much the beginning of the user experience field some 44 years ago. What I want to show you today is what I'm working on. And it falls into both of those two categories. So my interest is, number one, artificial intelligence is a functional material. It's no different than sound and light and steel and wood or anything else you design with. You have material in the digital world, you have material in the physical world. And that really falls into the UX for AI category. And then I want to show something a little bit more crazy, which is basically AI actually designing user experiences, which I have some relationship to as well. Now, before you get into a topic like AI, you need to define your terms. As Voltaire said, if you were going to converse with me, you must define your terms. And so I'm going to share with you a series of definitions just to set some context. And then I will show you two case studies, and then we can discuss, and I will attempt to answer questions. The first definition is really, what are the classes of artificial intelligence? And there's a lot of different words and ideas about this. From my perspective, in this bucket, there's three. There's hard AI, which is basically using neural net technology for pattern recognition, and everything is unstructured. An example of this would be showing a photo to an AI and having it tell you what species of animal it is. And it's not explainable, right? If you know anything about neural net computing, you can't ask why the software decided this was a cat or a dog or a fish. Soft AI is basically, of course, based on machine learning, but the assumption is that there's structured information. There would be some general domain rules, and the use of statistics is relevant in terms of finding what the most possible correct answer is. A simple example, which you're all familiar with, is Amazon recommending a book or something like that, where there's massive databases of relationships of what people have looked at, plus reviews, plus a bunch of other things. The gist of soft AI is it is explainable. There are models generally in the form of knowledge graphs. And then the third category is expert system, where there is a human way of doing this, and humans can codify the rules. And so, for example, and I could have a third case study depending on how our timing goes in the diabetes area, where you're trying to have a solution for patients to help manage their medication and exercise. So in effect, you as a human being can define the operative rules, and the software is just following them under the flavor of an expert system. So that's one definition. Now, any given product can use more than one class of AI. These are not mutually exclusive. My two case studies will fall into that soft AI bucket. Now, very important caution. Explainable does not mean you've gotten the correct answer. There's a big difference between validation and verification, right? So you could still be explainable and be wrong. Then definition 2, the degree of human agency involved, right? Is the goal of the AI to replace human beings, such as a self-driving car, or is the goal to augment human beings? At this point, my case studies are more in the augmentation area, though the second one starts to push at replacing human beings and might be able to get there. The third definition that I would speak about is the degree of risk. And this is true of automation. The photo on the right is an autonomous drone carrying a Gatling gun. I highly suspect that these kinds of devices are being used in the Ukraine right now, both by the Ukrainians and the Russians. This is not new technology. This is not, some of them are drones and they're remotely controlled with a camera. Some of them are completely autonomous. Very high risk, right? You have to ensure that you know who you're shooting at. And it's an area I have not worked in the military complex at all in my career for very personal reasons. Self-driving car is pretty risky. Designing something like an exoskeleton to move with humans and enhance human strength, and you see these in industrial applications today, the risk is lower, but you can still hurt somebody pretty badly if the exoskeleton does something crazy, right? So my case number 1 in medical is actually a very high risk case. And case number 2 is lower risk, but not at all without risk. And finally, I want to borrow from Ben Schneiderman's new book that just came out a few months ago on human-centered AI. And he has a set of definitions that I think are also helpful to get your head around this whole space. And he talks about AI metaphors. So he defines 4 classes of AI metaphors. Intelligent agents, like the self-driving car, is a robot. Super tools, which is human control of technology, but using artificial intelligence. And my case 1 study would be in that category. And AI is a teammate where it does something like human creativity, but maybe you're a partner with it. And my case 2 is kind of in that bucket. And then telebots, like the intuitive surgical robot that I had a picture of before, where the surgeon is really working in this artificial world, but the patient is on the table being cut up. So with those definitions now, I'm going to show you my work in user experience for AI and what kinds of things are going on. Now, I mentioned before, you know, the Amazon example, and the Amazon example does fit the class of soft AI. It does augment the human. It's there to help you make a decision, but the risk level is 0. If Amazon basically makes a bad book recommendation, nobody's going to die, right? But this next example is one that has very high stakes. And this is a solution from a company called Illumina, who is the largest producer of DNA sequencing instruments. So it's a genomics company. They make the instruments, they make the chemistry, and they make the software that surrounds the instruments and the chemistry both before and after the sequencer. This is very much after the sequencer. And what you are doing is looking at the entire genome for rare and undiagnosed disease of usually the parents, the child, and sometimes the siblings. So you're trying to figure out what is going wrong and what you can do to help a child. And it's a needle in a haystack. So the process is to find every variant in the human genome, map it to the phenotypes, which is how genes express themselves. So the color of your eyes is a phenotype, but also diseases and deformities, et cetera, can fall into that bucket of phenotypes, and figure out what the most likely rare diseases, or potentially even discover a new rare disease. The typical user is a PhD level genomics expert. And in a sense, their goal is to generate a report for the ordering physician that says what is going on in this human's body. Now, I don't want to get into a long explanation of the screens, but I just want to show you what is kind of going on. So the AI class is soft. The tool is very much a power tool, is to augment the analyst. And the risk level is extremely high because you're trying to figure out the diagnosis of someone who has some severe issues. And these are cases that are in the software, the case list, and you can see the phenotypes and you can see what's going on here. So we may have a phenotype like a high palate or a short neck, or an intellectual disability, right? We have phenotype is missing a thumb. Colon cancer is another phenotype. So you do need to know if there is actually anything pathogenic. So how complicated is this to do? Well, in a human being, you have approximately 3 billion pairs of DNA. They divide into 25,000-ish genes in 46 chromosomes in every cell of your body. And if you sequence a perfectly healthy human being, you would probably find at least 100,000 genetic variants of different types from a reference genome. So the fact that there is variation is not in and of itself indicative of a rare disease. And again, what you might see here is, in this case, the software is looking through massive knowledge bases that are curated by multiple medical and government health organizations around the world, so that pretty much every published article and research study in the world, changing every day, has to be searched. And it's coming back. And in this case, it said there actually weren't any most likely candidates. In all of that literature, there's 60-some candidates, and it's honing in on a particular gene variant, which is on chromosome 17 at this location, and they were expecting a G. So I don't know if you all remember high school biology, but you'll have G, C, T, and A are the markers, and they come in pairs. And it's saying here, where we expected a G, we got this entire long sequence. So this is something that's spliced into the genome and shouldn't be there according to the reference genome, but there's a correlation for a genetic variant at this location with deafness. So I hope you follow. This is something, there are probably 1 million articles and data points to check. And again, probably hundreds of millions of variants that can be tracked to some clinical research studies. So this is kind of the Amazon recommender on steroids. And again, you would see screens like, okay, these are different kinds of predictions. If it's an insertion in the genome, if it's a deletion in the genome, if it's something that should have been over here, but it's over there. There's all kinds of things that can go wrong, and we won't get into the genome. Also note that this particular gene problem, which is a C, was expected, and they found a T, and I'm not even sure which kind of encoding that is been found 18 times to be associated with cancer in the massive number of databases. And let's see, in this screen, yeah, it's telling you it used the UCSC browser, it used gene cards, it used PubMed, and it used WikiGenes. So those were completely different knowledge bases from which it could draw the conclusion that there's a relationship between this particular mutation in your multiple billions of DNA pairs and cancer. And again, the databases, the knowledge bases are being upgraded every day. Articles are refuted, new data. And this is just for finding rare diseases. Same technology can be used. And this is the goal, is to determine a diagnosis. I'm personally working on another product at the same time, which is for cancer treatment, where you know the diagnosis, and now you're trying to figure out, based on a human's genetic composition and the variants in the tumor, what chemotherapy would be most useful. So that's basically very personalized medicine. Now, it is explainable. A user with the PhD wants to know, how did you come to this conclusion, right? What's known to cause what? What are the relationships in the scientific literature? And in the cancer one, it looks for clinical trials, and it looks for at the chemolytic drug labels, as certain chemolytics are more or less effective based on certain genetic variants. It will look at population data, right? If you are a Pacific Islander, the particular variants may be extremely common and they were known to be benign. But if you see that same variant in a Caucasian, it might indicate trouble. And again, the amount of data, it would be infeasible for a human being to do this. Note, this is also the case for the mother, the case for the father, et cetera, et cetera. So I think you get the basic idea. You'll end up with a graph. And my work is basically making these user interfaces functional, making them usable, making sure that people can understand what's known to cause, and making them efficient. In rare disease, it can take anywhere from half a day to 2 days of the analyst to really dispatch a case and figure out what matters. In cancer diagnosis, it can be as fast as 5 minutes per case. And again, the result is intended to be this clinical report. We've sequenced, in this case, the whole exome, not the whole genome, which an exome is those genes responsible for protein production. That's the ones that basically determine how you grow. So it's a little less expensive than sequencing the entire genome. So the question then is, what is the most important thing from a user experience characteristic that has to be achieved for a product like this to be successful? So assuming it's accurate, right? Because if it's not accurate, you won't come to the right diagnosis and you won't help any people, and you will have just spent a bunch of money. So are we able to have participants answer in the chat? I'm not sure how the panel's set up.
Yes.
So tell me in one word, what is the most important thing that you have to get this genomicist expert to feel about your user experience design and the whole product, the whole system? One word. Somebody toss it out. I'll even give you a clue. It starts with a T. They have to trust you, right? Thank you. Yeah. Jan Eckert landed on it. They have to trust you. And trust is an incredibly complicated thing from an experience design. To take a detour into experience design and out of AI, right? To gain trust and be able to persuade people that you know what you're doing, you must achieve credibility. And credibility basically has a simple formula of perceived trustworthiness plus perceived expertise would equal perceived credibility, right? And so what do these things amount to? In the user experience world, perceived trustworthiness actually relates to the visual design quality, the usability, and of course, the technical accuracy. Now, if you're the user experience designer and you can't get the fields to line up and you can't make the fonts legible, why would I trust that your scientists actually have the algorithms to do this, right? If I'm the doctor, you send me an ugly looking report. Why would I think that if you can't make a report readable, you could actually do these calculations? Perceived expertise is about brand and recommendation. So a company that's the leading genomics company in the world has a brand associated with this. Would you trust Amazon to recommend what rare disease you have and how to treat it? Maybe not, right? So again, the whole point with this bringing in these kinds of recommender systems, and this is at the extreme edge of recommender systems, it's about trust and making sure and that the system can explain itself and that it's just very, very well designed in every detail. And there are different types of credibility, but I think I'll save, going into this in terms of what's on the surface versus earned, where you really have experience over time that yes, this software is giving you accurate diagnoses, right? But if you look at failing to deliver credibility, the main thing is you could do something stupid, like use a cartoon metaphor for a cancer website. Being in trouble is you cause the company to go bankrupt, and the disaster is basically you kill the patient, right? So there's a lot of failure points here. So I'm going to pause. I think we're in good shape. I'm looking at the clock, and actually field any questions you have about the world of designing user experience when your media and your technology is AI, and that's the core of the product. Any questions? You can throw them in the chat. I can see the chat if you're not able to speak through the panel. Okay, I don't see any questions. So either I'm totally unclear or everything was 100% clear. Okay.
The second option.
Okay, so I do see one. How do you base your decisions to make the job work? And I'm not sure how to interpret the question, Jorge. I would say that one of the things that's going on, on what basis do you improve the design? So the thing to consider here is you have to co-design this with the experts, right? The design team, actually our design team has multiple PhDs in genomics and several MD PhDs. But in the end, you have to work with the people who are doing it. And so there's really two threads. One is improving the usability, which is pretty much classic user interface design for efficiency, effectiveness, and satisfaction. How fast they can process the cases, how accurately they can share the information and communicate with all the people. And then there is the technical accuracy, which is its own separate thing. So when you do this kind, when you have to test this kind of software, you have both verification testing and validation testing. Verification testing says your code did what you think it was supposed to do. Validation testing is your code generated a clinically correct answer. Those are two completely different problems. And yeah, you definitely have to include the users. The patients do not interface with this. The doctors do not interface with this. The doctors write a medical order asking for a sequence and a report for any ideas on what rare disease might actually be the cause of these symptoms. So in this case, we're downstream, the DNA has been extracted, it's been sequenced, it's been quality checked, and then it's something called tertiary interpretation, right? What is the significance of the result? Okay, another question. What do you consider in a project in order to get information on what the requirements in regard to UX are? And what are the biggest challenges in the process? The requirements, well, people have been working on sequencing DNA and using the data now for a very, very long time. And so this is actually a pretty mature field. It's advancing very rapidly because of advances in computer science and AI, and reduction in cost. And so the requirements are really coming from people who are working on this themselves, either commercial laboratories or research laboratories at universities around the world. And they make requests for what they need next. Because if you don't do it, their own bioinformaticians are trying to do this by hand. And I don't mean by physically by hand, but writing their own software as compared to commercial process. So again, it becomes a co-design activity. You have a lot of stakeholders. They can tell you what they need. And actually the biggest clue for these kinds of systems is you do contextual inquiry activities for your discovery research, and you figure out what they're using Post-it notes in Excel and whiteboards and other software products that were not meant for genomics and aren't medically secure and confidential to work around all the deficiencies in the tools that they've already got. But it's classic human-computer interaction. There's nothing different in figuring out what the requirements are. And there's really not that much that's different in any of the patterns that would show up on the screens. But no human being, I mean, a human being might have to spend an entire career to get through one case if they didn't have the AI to filter through, you know, billions and billions of data points. So let's go on. Yeah.
There is another question in the Q&A. To design for something so complex, do you understand how the AI works technically?
Do I personally understand? Yeah. Actually, most of these products, and there are competitors to the one that I showed you, use a machine learning platform called Nirvana. And they basically upload every knowledge base, and they use the machine learning to cross-correlate everything and build a massive knowledge graph. So when they hit a particular variant on a chromosome, somewhere in those 3 billion data points, right? They can look up and find every article and everything that's published. And that doesn't mean the literature will agree, right? Some literature will say this variant is pathogenic. Some literature will say it's benign. So it's a massive data crunching, right? And your own data in the genome is like terabytes of data, just the actual you being sequenced. So it's pattern recognition, but it's structured data. So fundamentally, it's a math problem to just make all the correlations. There's no magic like in the neural net approach. Let me go on now, so we have time to look at the second case study. But I think you can see, hopefully, the extreme case of, there is no product here without the machine learning and the AI, right? Because it's beyond the human's lifetime. So now I want to talk about artificial intelligence creating user experiences. And I'm going to show you something else that I've been involved with for a few years. An AI that not only can do the design work, it generates the code for an entire user experience. The reference point is a startup company called Clean Software with 3 E's. And I took some of their marketing slides here. But effectively, the thing is, you as the user say what you need and why you need it. So you basically input the requirements. And through their pipeline, their AI, which is a generative AI, creates a product. And so assuming you put in the requirements, there's in their slides, they're basically constructing, again, a bunch of knowledge graphs. Some of the knowledge graphs are about the relationships of the data. Some of them are about the semantics of user experience design. And whenever you see words like construct graph and then prune the graph to figure out what piece of the recommendation it's going to use, this is all kind of different parts of AI. And there's multiple types of AI in this solution in order to generate user experience. Now, sounds a little bit crazy. This is an sample generated application for managing an automotive fleet. No human being designed these screens. There were no sketches. There were no prototypes. There was no graphic designer, right? So this is not the most complicated application in the world. This is not the cancer, the rare disease application that I showed you. But probably 95% of all the university IT departments and corporate IT departments that have to create lots of little apps to keep their organizations running are no more sophisticated than managing a fleet of cars. So again, this is completely AI generated experience. What's going on? How is this accomplished? Well, as I said, there's multiple UX and AI models. I just put in some random model diagrams here. I obviously can't show you the intellectual property for this, but you get the idea that there's a bunch of work to map the semantics in the requirements, and I'll define what I mean by semantics in a little bit more, into workflows and screens, right? And then there's a bunch of intelligence that maps that to aligning with the data. So the semantics, the workflows, and the personas to look at the data and the business problem to be solved, and then to map that to a UX library of design patterns and interface flows. I can explain this part. I can't actually explain that part, and I'm not involved in that part. Okay, so where does the logic that the AI uses come from? And in terms of figuring out the transition from requirements to semantics to flows and screens, it actually comes from a history of work on semantic interaction design that dates all the way back to Phyllis Reasoner in 1979 at IBM Watson Labs, and embodies a whole bunch of work by some really, really smart people. The beginning of it was captured in a book by Jeff Johnson and Austin Henderson in 2012 called Conceptual Models, and that's the first layer of 4. Both Jeff and Austin were on the original Xerox PARC team that invented the graphical user interface 35 years ago. In my book, I codify it to a much more sophisticated system that looks at semantics at the grammar level, the visualization level, the flow level, and also how to apply game theory to incentivize users to do certain tasks and flows instead of others. And so this company found me actually before the book was published, while I was writing it. I am not a founder of the company. They just found me, and it's a very funny way they found me. But they were working on this problem and they were stuck. But if you look at the semantics of user interfaces, right, we perceive user interfaces, graphical ones, as being comprised of actions, objects, and attributes, the attributes of the objects. A very simple one is, right, you see in graphical user interfaces, actions fall in menus of various places. You click on objects that you're manipulating, and objects have these attribute properties, right? And if you were to look at the user stories that are generated in almost any software methodology, but certainly in the Agile methodology, you can take the user story and you can forage for nouns and verbs. So in my book, I have a case study of a pet rescue nonprofit. And you can say, as a parent, person object, I want to find action, a friendly attribute, dog, animal object, that will help teach my children, person object, again, to be responsible, right? As an elderly widow, person object with certain attributes. Living alone, I want to adopt action, a dog object for my protection, attribute, okay? So if you look at any user interface, this is how it communicates to you, right? This is how you, through natural language, interpret every screen you ever see in the graphical user interface world. 5 billion people can do this today because that's the penetration of smartphones. It turns out, though, that the more consistent you are in your semantics, the lower the cognitive load. So I have designed 3 word processors in my life and redesigned a few. And early word processors were really bad, even before graphical user interfaces, where users would recognize objects to be a character or a word or a paragraph, but the commands were redundant and inconsistent, and it was a whole mess. And this is what I would call kind of the sparse grammar. And Larry Tesler came up with the idea at Xerox PARC 35 years ago of crushing the matrix down and making it very dense and making actions that transcend not only a single application, but the entire computing environment, like cut, copy, paste, which he came up with. And there's a huge difference in cognitive load. The denser the semantics, the lower the cognitive load. So when the semantics are dense, cognitive load grows roughly by the number of actions plus the number of objects. And when you get rid of all the redundancies and inconsistency, or you have them all, it starts to behave like actions plus objects. And you start to get exponential growth in the cognitive load that you're placing on people. And you can figure this out just from the requirements, even before you've drawn the first screen, which is a huge savings. And actually, AI is pretty good at figuring out what the densest matrix is if you type in a lot of ambiguous requirements. It will parse through and figure that out. So without taking an entire, I teach like an entire semester class on this, but I think you get the basic idea of what the semantics are. An action plus an object plus one or more actions equals a task in a graphical user interface. And then you have the flow level, et cetera. So what I want to just show you very quickly are some screens here. I'm not going to try and explain how you use the authoring tool, but as the user, and the user can be a software developer, but it's often just a product manager or a business analyst. You have the workflows you're trying to create. This is for an application that runs in a bookstore, okay? And you have a screen like, what is the objective for the user, the workflow's user story? Who's the persona? What is the verb? So they don't use the word action. They actually do nouns and verbs, but this is actions and objects, right? What's the goal, right? Et cetera. Select the experience. I want to enumerate a bunch of information, or I want to gain understanding. If you say, we want to gain understanding, then it's going to head in the direction of a dashboard UX design, right? If you say, I need to enumerate and manipulate data, it's going to go more towards tables and controls like that. You can create some of your own, et cetera. It has this catalog of things. A thing is a data object. A thing is actually, consider this the database schema, that you need to explain what the data is that you're working with. right? This is not, sometimes this can be deduced by reading the APIs. The artificial intelligence can look at the APIs and the database knowledge base and figure this out itself. But this is what it thinks the data is that's being manipulated. The tool, and this is one part of the AI, creates a model. This is a real diagram from the product. This is its understanding of the data that it is going to have to connect to generate the experience. So taking the models of the user stories, pulling out the semantics, mapping that to various goals and flow intent, it generates code for the entire application. And then you have a screen where you can launch your prototype, you can play with the user interface, and you can also make suggestions back to the AI. And eventually you export your code to GitHub and you publish it to the Amazon cloud or the IBM cloud or the Oracle cloud or whatever. It doesn't actually care. And it uses all the major UI development toolkits. It doesn't care if it's React or if it's Google Material or whatever. It's pretty broad. And boom, it creates a user interface. And you would not code any of this, nor if you click the add book button, would you code the screen, the form, where you would put in all the metadata that describes the new book that you're going to put in your store. In the visualization layer in the UX Magic book, there's also a decomposition which is used inside the product. And so, for example, we have boxes and letters and buttons in the component level. We have widgets. The system can also design custom widgets for you. You have to explain what the insight is that you want. And you kind of go through this wizard and explain the insight and whether there's aggregation of the data in the wizard or whether there's no aggregation. And effectively, it starts to build components for you. And in this case, if I basically explain what my desired insight is and what data and what persona, it would generate this bubble chart graphical widget as being appropriate to the persona and sufficient to reach the goal. And then, of course, that widget would be put into one or more of the overall screens. So it operates up that pyramid of the decomposition of the visualization layer. And so it also changes themes and it changes languages. It can do all of that automatically. So you're not messing with the graphic design. And you just have to put in your standard string translation tables for languages. So this is part of a larger movement in the tech industry for low code and no code solutions, because we don't have enough developers to solve the IT backlog. We've never had enough developers in my career, and I don't think that's going to go away. But it has an interesting question for you guys. And I know you're in kind of a design strategy program, but if an AI can do all of this and write the code reliably, what's going to happen to all of you who want to have a career in UX design or in software engineering? Where will the jobs be? So let's have a minute to talk about that. Where would the jobs be? Will there be such thing as a UX designer in the future? Can we take a vote? Do you know how to use the voting feature in the panel in Zoom?
Yeah,
you should have it.
It is, I think, activated.
So ask a question. Will there be UX jobs in the future? Yes or no? And let everybody vote. Oops. Are you finding the feature?
I'm having trouble with the future. Is this a test?
Not a test, but it's obviously not great usability. But anyway, so let's go back to the chat. Somebody offer an argument why there will be UX jobs in the future and or how those jobs would change. Or maybe there won't be jobs. Okay, so I see it. So go ahead and everybody vote, yes or no. Oh, hosts and panelists can't vote. Okay, so I can't vote, but I see the poll is up. Are we getting some results?
Yes. Yes, 82%, no, 18%.
Okay, so 80% think there will still be UX jobs in the future.
Yes, 82% thinks there will be UX jobs in the future.
Okay. I don't know the answer to this question, but I will be retired before it matters. However, some of you won't be. I would tend to say yes, there will be, but I think what we will have is product design jobs, right? So let's go to the next question here, because what's the obvious weakness of this kind of generative solution, right? One sentence can tell you everything you need to know. Well, I hope you're impressed with the technology, but it has an Achilles heel, a very obvious one. Anybody want to say what it is? Garbage in, garbage out, right? Now, the software actually does have empathy, right? And it figures out the empathetic need of every persona, which is a whole separate lecture on what's a real empathetic need and why personas are done wrong by almost everybody on the planet. But it actually can make associations about people's emotional need. But basically, you're inputting the requirements. If you don't get the requirements right, you may get a really beautiful functional user experience that doesn't do anything anybody cares about, right? So what I think is going to happen is the design community will, by definition, up-level itself to taking a much more holistic view. And I find that on the majority of my consulting time is really spent in what I would consider to be product management work and figuring out what to build, either with the genomics experts or with the users of a tool like this or any product. Crunching out a competent user experience is a known process, but you can make a really great user experience for something that is of no importance or no use and will make you no money and get no users. If you don't have the requirements right, it doesn't matter. So this AI is totally locked into the weakness of garbage requirements equals a garbage solution, no matter how pretty it looks. And by the way, it takes 1/100th of the time to create a running application or less, right? Even 1/1000th of the time. If you put in the requirements, you can do this in a day. Once you understand how the semantics model works, that it could take you months and months to write the code and test it. So the economics are very favorable. Okay, and then the other question is, will AI ever be able to solve for that weakness? So let's take another poll real quick.
Daniel, do you want to answer in the chat or shall I write the?
Well, you can go ahead. I'll continue, but go ahead and put the poll out. Okay.
Okay. I am afraid I don't know how to do it.
Well, you did it once already, but okay, let's move on.
Yeah, because
okay.
It tells me share results, but I cannot go back to create another poll.
Okay. Well, you could share, yeah, hit the share results button. Anyway, so I don't know the answer to that last question. My intuition is no. My intuition is that there's too much contextual soft information associated with truly understanding the requirements and understanding the domain. So a domain for a bookstore, creating the model that can understand a bookstore or a car rental application is viable. The cost potentially to create the AI model that could generate the genomic solution that I showed you is probably greater than the cost of generating the genomic solution by hand, right? Because you have to validate everything, right, and make sure it works. And you only need 2 or 3 of those applications in the entire world. You don't have thousands and millions of them you're trying to generate. So I think the main message is you should be mindful of how your careers will be affected by these 2 megatrends. The need to deliver experiences for smart systems, very smart products beyond the scope of human capability, and to what extent AI can help solve the problem. In this case, I didn't really show it to you, but in the clean software case, it actually recommends multiple designs to the user. And the user kind of says, I like this one, I think is better, but maybe this part of design A and that part of design B, give me that alternative. So in effect, you are guiding, the user is guiding the clean software. It doesn't come up with one solution, it actually comes up with many. And so you iterate, but you can do this again in a day and have a working application. So what's going to happen? I don't know. If I could predict the future, I'd be, a very, very wealthy person. But I can't. So that's it. I'm just, again, that's my life. I don't know if there's any questions on case study 2 or general questions. We have a few minutes left.
There are some questions in the chat.
Okay.
And some answer to your previous questions.
Yeah. So Richard said, will it be able to do the requirements? He said, maybe not, but it will probably keep getting better at it. I think that's probably true. Jorge said, you can't have a yes or no answer. It's a kind of bogus question. It's not that simple.
And then we have some questions in the Q&A, and it says the data visualization methods in this tool are really fascinating, but how does AI know which visualization method is the right choice?
Based on the user's goal. It's actually very simple. I teach a data viz class, actually, for grad students. If you want to show trends, you use a line chart. If you want to show differences, you use a bar chart. There are very well-known and codified at the expert system level books on which types of visualizations to use given particular types of data and particular goals. I had nothing to do with that part of the clean software. I think they used a number of books from Stephen Few, excuse me, Stephen Few. Okay.
There is a comment from Saul. It says, no UX shops. I think will be more consulting, making the existing AI-generated tech better.
Could be. I think, as I said, there will be a lot more product focused and to get the requirements right and put all the creative energy on asking the right questions, which is a much harder thing to do than cranking out a bunch of code, templatized code. Do you see much resistance to people taking up AI-generated work? Yeah, designers don't like this. They're scared of it, for sure. It's beginning to get a lot of traction with underfunded IT departments that can't even afford a designer. And so instead of whatever crap they would create on their own, they can be much faster in code generation. So the value proposition is very clear, but they can get a much better design because they don't even have a designer or could afford to hire a consulting designer. But it does get some pushback. It definitely does.
Daniel, being aware of time, I know you have an important meeting coming. What will be your message for the students? So what is the one skill that they need to develop to work in this context that is emerging?
I think the main message is, and somebody sort of pointed it out in the chat, and I forget which famous techno person said it, but the future is already here. It's just not evenly distributed, right? Everything is changing all the time. You as a student and as a practitioner in any field, particularly technology related, need to be a lifelong learner. Mm-hmm. Everything is changing all the time. You need to be aware of all of these mega trends, and you need to make the investment to keep up, right? To me, I look at it like surfing, right? Big waves, learn to surf, get a surfboard, ride the waves, because the acceleration that I've seen in my 40-year career is nothing compared to what you're going to see in the next 30 years, right? Because the rate of change just gets faster and faster. I make a goal of reading a minimum of 10,000 pages a year of technical and related literature in my fields. And I don't even think that's sometimes adequate to keep up. But that's basically it, right? I barely passed high school biology, and I've designed 2 genomic sequencing instruments and 2 large applications, one in front of the instrument and what I'm showing you after the instrument. You just have to learn this stuff constantly. So let's wrap. Thank you for inviting me. I hope you found this interesting. It's just a view into a day in the life of me, working in the middle of Silicon Valley, juggling lots of balls, doing many different things.
It has been very nice, Daniel, very interesting, very illuminating. I don't see that you see every day. So at least for me, is very new. Thank you very much for the time and for sharing your experience with our students and our community.
Oh, you're welcome. Thank you for inviting me.
Thank you. Bye.
Okay.
Bye.
See you at the next meeting. Bye.
Bye.